infrastructure is across the Northeast Asia, the supercomputing centers for open science and the KRP status. And I want to skip the background of CREONet and what is CREONet and the KRP status in Korea. And we have a vision for this develop this national science infrastructure to make upgrade. And this is the real, the steps is how to deploy or apply for our supercomputing data center, something like that. This is the Korea Research Platforms is the architecture and how to work in this, the part of the 3 or 4 sections. And I want to explain about the focus of this project. Related project is A3. A3 meaning is ASEAN countries, Korea, China, Japan, the 4-side program. The name is, as I first mentioned about that. So this project is belong to the APRP working groups. It's the first project is from the TAIN and Asia Connect project. As you know, the name is building on the high bandwidth distributed HPC. The reason proposal to the TAIN and the public international public fund, how to make infrastructure or the research platform based on the high bandwidth environment, such like NN, the PAN, the CREONet, TAIN, or APAN, to provide the member of the APAN in order to the smart brains is running their Python code and running the GPU program and something like that. And every country is not equal to using the IT infrastructure. And some advanced countries can donate the partially the computer resources. As the container technologies is very essential for those the projectors. So this project is the 3 countries is the proposed. Each country is a national the science foundation and together the world together award. So we got the totally this project. The main title is as I mentioned before, and the Korea subtitle is the research on the building high bandwidth distributed HPC based on the high compression metadata of AI technology. The participant countries Korea, Japan, China, and the duration is during this August of 2024 to July, bottom of July is 2029. And the budget is Korea in the $264,000, and Japan is $347,000. China is the $562,000. It's totally around $1 million. And the PI and the co-PI, and this project is the PI is the Hidetomo the Kaneyama from Riken and Japan. The Riken Institute is the inventor and the operation is a K computer. And the Yutung Lu is he came from this China, and the co-PI of China, the NSCC, Guangzhou Supercomputing Center. As you know, the Guangzhou Supercomputing Center operation is a 1001 and the 1002 supercomputer. And the Korea is on me and from KIST in Korea. And the objective, our final goal is described in the boxes. According to this boundaries of the advancement of science and technology, though the LLM or the large-scale language model and the advancement of the science and technology without binaries through the open science. This project is aimed to lead the development of an advanced research environment, system, and the element technology for the utilization and the sharing of research data, and to establish the infrastructure for sharing advanced research data between Korea, China, and Japan. And those that pictures is the basic architectures is between among the 3 countries, the what we need and what we built. And this is our project is a strategy. We divide into the 4 units. The first unit is the infrastructure unit, the leading by China, and the second unit, the data transfer, the leading by Korea. It means that the science DMG and the big data transfers, what we the talking is so far in APRP working group. And the unit 3 is the data compression part, reading by Japan. Unit 4 is a metadata unit, reading by Japan. The below box is how to the combination, the each unit is to make a promote is the support our the goal of this project's aim. And the more detailed technologies, so what technologies is combined each unit? And the first unit is the infrastructure unit, the data sharing file system across 80 supercomputing centers, and the data placement optimization and the fast access, and the HPC environment building and the integrations. Chinese are always is wondering about they have the, several and a lot of supercomputing centers is distributed, but all supercomputer centers is running a standalone. It means that is isolation. But at this case, they want to build to make this the link, the high bandwidth research network, and they want to using the big one supercomputer. At that time, it's the following the technologies, how to build a file system and how to transmission the big data, how to communicate the CPU and the GPU combinations. The unit 2 is the data transfer units, is the core technology, science DMG network deployment and accelerating of the long distance transfers, and finally is build a mutual trust zone and the secure transmissions. The unit 3 is the data compression reading by the Japan, the lightweight data compression technology, and the AI-based compression algorithms. It means the AI algorithm deployed for the how to make the index areas. We can call it metadata. And the third technology is a TE-GIP, the extension. Already the invent is the prototypes is how to the compression data through this TE-GIP technology. The unit 4 is metadata unit reading by Japan also. The FAIR metadata design. The FAIR is the suggestion by this the global the community of the how to metadata is make this the efficiency for the file system. And the second thing is cross-disciplinary and international models, and finally open science support. And so those technologies, it combinations each unit and to make the further technology models to support our the A3 project is the aims. Conclusion is the three categories. The first one is HPC over HPN. It comes from this Korea status. HPC and over HPN. HPN means a high performance network. The Korea is a 25 government funded national institute. Already they have the high speed research network installed. We want to using the big data infrastructure and make the sharing or distributed HPC or super facilities they have. So, and then, and the A3 project is the involve or the many the institutes, the unique facility or supercomputers to share or the big coverage, make the big coverage to their research areas and make this upgrade the utilization and the deeply collaboration. The currently deeply collaboration is the very the beginning steps. It's just communicating email or some this transmission and exchange data. But deeply the collaboration is the running on the system level. It's all kind of this automatically the layers. So all those kind of things is the detailed expression of the conclusion part. So after all, and the APRP and the high bandwidth is distributed HPC like or the super facilities is very important to the fair upgrade fair upgrade is all research domains in ASEAN regions. So APRP working group and such like those projects, the finally support our aim and our dreams and visions. Thank you for your listening. And sorry for over the 15 minutes, and could you please out there enjoying the break time. And we restart again at 11 o'clock. Thank you.